All right, today we're diving into something, well, something pretty wild. It's a radically new way of looking at the atom, and really the entire universe. It's called the harmonic scale framework, and it tells a completely different story about how reality's most basic building blocks work. And it all kicks off with a simple, but surprisingly tricky question.
So, to really get why this framework is so fascinating, we've got to start with a classic physics puzzle. You see, if you take a nucleus and you weigh the individual protons and neutrons that make it up, their combined weight is always more than the finished nucleus. So, where does that mass just disappear to?
Let's make this real. Take a helium-4 nucleus. You've got 2 protons and 2 neutrons. On their own, their total mass energy comes out to about 3,755 mega-electron-volts. But once they fuse together, the final nucleus is only about 3,727 MeV. That's a gap of 28.3 MeV that's just gone. So where did it go?
Now, I know what you're probably thinking. E equals mc squared. And you're right, that's the famous textbook answer. The missing mass hasn't vanished, it's been converted into a massive amount of energy that we call binding energy. It's the very stuff that holds the nucleus together and powers stars. But just putting a label on it doesn't really explain how it happens, does it?
And that is the real question, isn't it? What's the actual physical process? What's happening under the hood that turns that mass into energy when particles get together? Just saying the strong force did it is kind of like saying magic happens. It doesn't tell you the mechanics. And it's this exact mystery that the harmonic scale framework tries to solve.
So, to get the HSF explanation, we have to learn a totally new language for reality. Forget thinking about little billiard balls. This framework says that everything, and I mean everything, is actually a combination of 5 fundamental waves.
These are called the 5 K channels, and they handle everything from a particle's mass to its electrical charge to its shape. But for our puzzle right now, we only need to zoom in on one of them. K4, the Neutrofield. The easiest way to think about this one, it's like an internal energy storage depot inside every particle.
All right, so this K4 channel, this is it. This is the absolute key. In the HSF model, K4 is the hero of our story, the thing that's going to unlock this whole mystery of binding energy.
So picture it like this. Every particle has an internal battery. That's K4. And it's not just holding a little bit of charge. We're talking almost all of it. Over 99% of a particle's entire mass energy is packed away inside this K4 channel. It's the massive power source hiding underneath everything else.
And here is the absolute game changer. This internal battery, it has a limit. It's not a bottomless pit. It can get full. And this concept is called saturation. You just can't keep cramming energy into it forever. There is a hard physical limit to how much it can hold. Honestly, this is the single most important idea in this whole thing.
Because with that one simple idea, we can finally solve our puzzle. Binding energy, in this new story, is simply the overflow from an energy depot that got too full.
You see how different this is? The standard view says a mysterious force creates energy from mass. The HSF view says, nope, the energy wasn't created, it was just expelled. It's the leftover energy that simply couldn't fit inside the new combined storage tank.
It's a really intuitive 3-step process. First, the particles merge, and they pour all their individual energy stores into one big shared depot. Second, that shared depot immediately fills to the absolute brim. It becomes saturated. And third, any energy that was left over, that couldn't fit, gets violently kicked out. And that expelled energy is what we measure as binding energy.
And the scale here is it's incredible. For a normal nucleus, well over 99% of all that starting energy stays safely tucked away inside the new K4 depot. It's only that tiny fraction, often less than 1%, that overflows and gets shot out. And yet, that tiny little sliver of energy is powerful enough to light up stars and run our nuclear plants.
Now, what makes this whole idea so compelling is that this concept of storage, capacity, and overflow isn't just a one-trick pony for binding energy. It actually becomes the foundation for explaining a whole lot more about physics.
For instance, what we call the strong force is just the effect of these K4 energy balloons merging together. The framework also reimagines quarks not as points, but as complex waves. And it suggests a proton is so stable because its internal waves are in perfect harmony, while a neutron decays because its harmony is just a little bit off, and it has to spit out some overflow energy to fix itself.
Yeah,
The source material puts it beautifully. The strong nuclear force is the energy drop when K4 bubbles merge. See? It's not some kind of magical glue. It's just the natural result when particles merge their energy fields to find a more stable, lower energy state.
So the big takeaway here is this massive paradigm shift. The harmonic scale framework is suggesting we stop thinking about a universe run by 4 fundamental forces and start thinking about a universe governed by things like geometry, wave harmony, and most importantly, the simple physical limits of storage capacity.
And that really leaves us with a pretty provocative thought to chew on. What if the universe isn't really about pushing and pulling? What if it's more about filling and overflowing? What if the most fundamental laws of nature aren't about forces at all, but about capacity and the simple, powerful consequences of hitting a limit?